Hello viewers, welcome to Deepu's Chem classes. So I'm putting videos based on 11th Chemistry Tamil Nadu syllabus. So please utilize this video and kindly pass to all the 11th students so that they will be benefited. So today's class is about the chemical calculations, the continuation. So today we are going to see about oxidation, reduction and oxidation number. So let us see what is oxidation and reduction comparatively. So oxidation, you may see some changes in day-to-day life itself. For example, when you cut an apple and when you keep in an open atmosphere, what will happen? It will be changed into brown color. Or the iron, it is actually silvery white in color in pure form. But when you kept in air continuously, when it exposed to moisturized air, it will be changed into brown, reddish brown. That is actually we called that as rusting. Okay, so similarly, so many examples you can say for oxidation and reduction that will be held in our day-to-day life. So let us see definition orientedly what is oxidation. Addition of oxygen is said to be oxidation. For example, so here we are taking iron Fe. When oxygen is added to iron, it forms ferric oxide Fe2O3. Or simply you can say iron oxide. So addition of oxygen is said to be oxidation. Okay. Similarly, addition of hydrogen is said to be reduction. Okay. Addition of hydrogen is said to be reduction. For example, when hydrogen is added to sulfur, it forms hydrogen sulfide. So in this case, hydrogen is added to sulfur element. Okay, so additional hydrogen is what? Reduction. Okay, then removal of hydrogen, you can say the reverse of addition of oxygen. Removal of hydrogen is also said to be oxidation. For example, H2S plus Cl2. So in this, from hydrogen sulfide, hydrogen is removed and which is added to the Cl2. So from hydrogen sulfide, hydrogen is removed. So H2S is not here oxidized. Okay, so you can get a compound HCl plus sulfur, hydrogen chloride plus sulfur. Okay, then removal of oxygen, the reverse of addition of hydrogen. Removal of oxygen is also said to be reduction. For example, from copper oxide CuO plus carbon. Okay, what is removed from copper oxide? Oxygen is removed and which is added to CO. So from copper oxide, oxygen is removed. So copper oxide is said to be reduced. Okay. Then in the basis of electron concept also you can say oxidation and reduction. Loss of electron is said to be oxidation. So for example, Fe2 plus ion, when it loses furthermore one electron, it will be changed into Fe3 plus ion. So whenever an ion or atom loses electron, it gains positive charge. That's why it is given Fe2 plus. When it loses electron, it becomes 1 plus charge is increased. So you can get Fe3 plus. Then gain of electron is said to be reduction. For example, C2 plus plus 2 electrons. Okay. So the 2 plus deficiency is satisfied by the addition of 2 electron. So simply you can get copper element. Okay. So whenever electron is gained, the number of charges will be decreased. Okay. So 2 plus will be balanced by the addition of 2 electrons so that we can simply get Cu. Here the no, it carries no charge, simply zero. Okay, zero oxidation state, you can say. Right. So, based on electron concept only, oxidation is shortly abbreviated as LEO. That is, loss of electron is said to be oxidation. And reduction is abbreviated as GER. That means gain of electron is said to be reduction. Okay. So, just giving you comparatively what is oxidation and reduction. So you may also write separately these points for oxidation and 3 points for reduction. Okay. Then let us see what is oxidation number. The residual charge possessed by the atom is said to be oxidation number. For example, now only we have seen copper, copper 2 plus. Then what is the charge possessed by the copper atom here? 2 plus. Okay, then the oxidation state of copper is 2. Okay, plus 2. So now it is given Na plus. what is the charge possessed by Na here? Plus 1 you can say. So the oxidation state of sodium is plus 1. So similarly, you can say for negative charge also, Cl minus. Then charge possessed by chlorine atom here is minus 1. So the oxidation state of chlorine is minus 1. Similarly, for oxygen, you can say O2 minus. So the oxidation state of oxygen is 2 minus. So simply it means the residual charge, okay, the charge possessed by an atom, okay, or element, you can say, or element. That is actually called oxidation number. So here they have given certain points to remember the oxidation state of certain elements easily. So let us see one by one. So among that, the first one is oxidation state of a free element. So if it is an element, for example, simply Cu or simply Na, it carries no charges. So if it is an element that may be in uncombined state, it doesn't combine with any other element, then the oxidation state of such element is 0. Okay, if it doesn't carry any charges, or if it doesn't combine with any other element, simply it is in free elementary form, then the oxidation state of those elements are called 0. It not merely be a monoatomic atom, it may be a diatomic atom also, but it should have 0 charges. So you can say elementary form H2, Cl2, Na, Sa, they are all remains in the elementary form, so their oxidation state is 0. Okay. Then the second point, for a monoatomic ion. So now only we have seen Na plus. What is the charge possessed by sodium here? Plus 1. Then the oxidation state of sodium is plus 1. Okay. What is the charge possessed by chlorine? Minus 1. Then what is the oxidation state of chlorine? Minus 1. So similarly, if it is an ion, monoatomic ion, we should consider their net charge of the ion as the oxidation state. Okay. Then third thing, the algebraic sum of oxidation states. Suppose if it is a compound, if it is a molecule they have given. For example, you can say simply HCl as the example. Okay. So for HCl, if it is a molecule or if it is a compound, then their net charge. Net charge means that is we don't have any exponent on the compound. That is actually net charge. So in some compound we have some exponent charge, residual charge. Okay, so here there is no charge, it is net charge is 0. So if you add the oxidation state of the individual elements in the compound, you can get the net charge of the compound. For example, for HCl, for hydrogen, the oxidation state of hydrogen is plus 1. For chlorine, the oxidation state of chlorine is minus 1. So if you add, you can get plus 1 minus 1 0. That is actually the net charge of HCl. So you can say for other atoms also, for example, CO3 2 minus. Okay. For carbon, the oxidation state of carbon is plus 4. Okay, plus 4. This is actually a carbonate radical. It carries 2 minus as the net charge. So carbon, the actual charge of carbon is plus 4. Oxidation state of carbon is plus 4. And for oxygen, it is minus 2. For 3 oxygen, it is 3 into minus 2 equal to plus 4. 3 into minus 2 is minus 6. So plus 4 minus 6 you can get minus 2. So which is nothing but equal to the net charge present on the radical. So whether it may be a ion or a simply compound, their net charge is nothing but equal to the algebraic sum of the oxidation state of all the atoms present in a molecule. Okay. So that is an example given for sulfuric acid. So I am writing clearly. For hydrogen, 2 hydrogen it is 2 plus. For sulfur it is plus 6. For oxygen 4 into minus 2. So it is plus 8 minus 8 equal to 0. That is the net charge present in sulfuric acid. Okay. Then next one, similarly for our ion and radical they have given. I have given you example CO3. So here sulfate radical is given. For sulfate radical, sulfur oxidation state is plus 6. It is 4 into minus 2. So plus 6 minus 8 equal to minus 2. That is actually the net charge present in the sulfate ion. Okay. The next point to remember is, for in most of the compounds, hydrogen has the oxidation number plus 1. except in the metal hydrides. In metal hydrides, the oxide, because metal is highly electropositive in nature, so automatically hydrogen carries a negative charge. Okay, so for hydrogen in metal hydrides, the oxidation state is -1. So except the metal hydrides, in all other compounds have hydrogen in +1 oxidation state. Okay. So for example, they have given in HCl, okay, it's simply a compound. Okay, for hydrogen, HCl, hydrogen carries +1 because chlorine is a highly electronegative element. It always carries the -1 charge oxidation number. So hydrogen automatically carries +1. But in case of metal hydride, sodium is a highly electropositive metal. So it always carries +1. So hydrogen automatically carries -1. Okay. Then fluorine is a highly electronegative element, the first most electronegative element in periodic table. So always its oxidation state is being -1 in all compounds. Okay. Oxidation state of oxygen in most of the compound is -2. Certain exceptions are here. In compounds like peroxide, superoxide, and compounds with fluorine, the oxidation state of oxygen will be varied. Maybe -+2, -1, +1. Likewise, it will be varied. So another point, in periodic table, the first group elements, that is 1s block elements, or otherwise it is called alkali metals, always have the +1 oxidation state. Then in second group elements, that is actually called 2s block elements or alkaline earth metals, always have the +2 oxidation state. Okay. So in all their compounds, this is actually extra given. It's not okay in all their compounds. So certain examples are provided here. In each compound, we are going to find out the oxidation state for a specific element. So let us see in carbon dioxide. So let us find out the oxidation number of carbon. So for which element we are going to find out the oxidation number. So for that element, we keep them as X. Okay. So the element whose oxidation number to be find out is considered to be X in the calculation. So, so for carbon dioxide, we just consider carbon. I'm writing here for carbon dioxide. For carbon, we consider them as X because that's a thing we are going to find out that is unknown. So we consider them as X. Then in the general points we have seen, for in most of the compounds, the common oxidation state of carbon dioxide oxygen is -2. So here 2 oxygen is present. So 2 into -2. And for carbon dioxide, there is no net charge. So net charge is 0. So we just equate them equal to 0. So x 2 into -2 is x minus 4 equal to 0. Then bring this -4 to another side. So it becomes +4. So x equal to +4. So what x is nothing but we have considered here for carbon. So the oxidation state of carbon is +4. So this is the way we have to find out for all the compounds. Okay, so the second problem is we're going to find out oxidation state of sulfur, that is unknown. So for sulfur in sulfuric acid, the formula is H2SO4. So for we have to keep sulfur as X. So for hydrogen, the general common oxidation state is +1. For 2 hydrogen, it is 2 into +1 plus sulfur is unknown, let it be X. Then for oxygen, the common oxidation state is -2. For 4 oxygen, it is 4 into -2. The net charge, there is no net charge on the compound, so it is equated to 0. So 2 plus X minus 8 equal to 0. Plus 2 minus 8 becomes -6. So x minus 6 equal to 0. X equal to +6. So for sulfur, the oxidation state is +6. Then the next compound, chromium. For we have to find out the oxidation state of chromium in dichromate ion, Cr2O7, the whole 2 minus. So it carries actually a net charge. So Cr we are to going to find out. So let it be X. 2 chromium is there. So it is be 2X. Then for oxygen, the common oxidation state is -2. For 7 oxygen, it is 7 into -2. There is net charge on the compound. So which is equated to minus 2. So 2x minus 14 equal to minus 2. 2x equal to minus 2 plus 14. So which is equal to plus 12. X equal to bring the term 2 to another side. So it comes under division. So plus 12 divided by 2 becomes plus 6. So the oxidation state of chromium is plus 6. Okay. Similarly for carbon in CH2F2, that is difluoromethane. Okay. So here you have to find out in the same way. Let carbon be X. For hydrogen it is plus 1, 2 into plus 1. Then fluorine it is minus 1, 2 into minus 1. So 2 plus minus 2. So it becomes 0. So the oxidation state of carbon in difluoromethane is 0. Okay. Then for sulfur and sulfur dioxide, sulfur be let sulfur be X here. For oxygen it is minus 2. 2 oxygen is there. So 2 into minus 2. So X minus 4 equal to 0. There is no net charge. So it is 0. Equators is 0. So X minus 4 equal to 0. X equal to plus 4. So sulfur oxidation state is plus 4 here. Let us see remaining in the next video. So please like my channel, subscribe my channel and share my videos to other users also. Thank you.